Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at table-r Institute of Technology. In previous sessions, we have seen about memory management and memory management techniques. In memory management, we have seen about swapping, and memory management techniques, we have seen about contiguous memory allocation and non-contiguous memory allocation. So, in this session, we are going to see about structure of page table. So, what is the overview of this presentation? Let us see our overview of this presentation. In this overview of this presentation, we are going to see about structure of page table, segmentation, virtual memory and demand paging. So, we are going to see about what is the structure of page table and how we are going to segment each table and what is the need of this virtual memory and what do you mean by demand paging. So, first, structure of page table. Page table is a data structure used by virtual memory system to store the mapping between logical addresses and physical address. So, here in this page table, it is a like data structure and it is used by virtual memory system to store the mapping between the logical address and physical address. How we are going to map with the logical address and physical address. Logical addresses are generated by the CPU for the pages of the processes. So, here the logical addresses are generating by the CPU for each pages and that processes therefore they are generally used by the processes. So, the logical address will be generated by the CPU for each page and the processes therefore they are generally used by this all kinds of processes. So, all the type of processes can be accessed by this logical address. So, physical addresses are the actual frame address of the memory. They are generally used by the hardware or more specifically by RAM subsystem. So, RAM is nothing but random access memory. So, here the physical addresses are the actual address frame of the each memory and they are generally used by the hardware that can be specifically used by RAM subsystem, random access memory subsystem. So, how the logical address space is used? So, logical address space with M words and logical address space is used by L words. So, for page size we are taking as P words. So, when you are comparing with the logarithm, so log 2 of m is m bits, log 2 of l is 1 bits and page offset is log 2p p bits. So, m bits, l bits, p bits. So, these are about logical address, physical address and page offset. So, structure of this page table, how we are going to page each frame number and how we are going to map with physical address and logical address. So, this is what about page table and these are page numbers and these are frame numbers. So, frames are nothing but each frame consists of each page number and this frame number and this is frame offset. So, physical address m minus p and this is p bits m minus p. So, total is nothing but m bits, memory bits. So, logical address, frame number, frame offset. So, logical minus p, L minus p and p is offset here and it consists of L bits. Number of entries in page number equals to number of pages in each process. So, entries of page table is equals to number of pages in the page process. So, page table size is 2 of L minus P into E bytes. So, E is equals to M minus P of frame size bits. This is how we are going to map with the page table, page number, frame number and frame offset and how we are going to map with physical address and logical address. So, next is segmentation. A process is divided into segments. So, each process is divided into segments. The chunks that a program is divided into which are not necessarily all of exact size called segments. So, the chunks that a program is divided into which are not necessarily with all the extra sizes are called segments. So, whatever the extra sizes of each bits or each segments that can be having some exact size. So, that size is divided, that sizes are called as segments. Segmentation gives the user's view of the process which paging does not provide. So segmentation gives the user view, whereas the in paging that is not possible and it is not be provided for the paging. Here the user's view is mapped to physical memory. So here the user view is mapped to physical memory. Next, what are the different types of segmentation in operating system? So there are two types of segmentations in operating system. What are they? Virtual memory segmentation and simple segmentation. So virtual memory segmentation is nothing but each process is divided into number of segments, but the segmentation is not at all done at the same time, means not at all done at once. So each number of segments are but not the segmentation cannot done all the at a time. So all cannot be done at once. This segmentation may or may not takes place at the runtime of the program. So that segmentation may or may not take place at the runtime of the program. That is what about virtual memory segmentation. How it is dividing? So the process divided into segments, but the segmentation is not at all done at once. So the segmentation cannot be done once at a time, means it cannot be done all the at a time. The segments cannot be done at a time. The segmentation may or may not takes place at the runtime of the program. That is what about virtual memory segmentation. Simple segmentation, each process is divided into number of segments. So here each process is divided into number of segments, all of which are loaded into memory at runtime through some not necessarily contiguously. So it is not necessarily or contiguously loading into the memory at runtime. So in virtual memory we have seen the segments cannot be done at once, whereas in this simple segmentation each process is divided into number of segments and that loaded into the memory during runtime. Whereas there in virtual it cannot be done, and in this it cannot be done necessarily or continuously, it cannot be done. That is what about simple segmentation. There is no simple relationship between logical address and physical address in segmentation. So there is no any relationship between logical address and physical address in the segmentation. A table stores the information about all the such segments called segment table. So table which stores the information about all such segments is known as segment table. The segments each consists some information is stored in the form of table that is known as segment table. This is what about segmentation. So how we are going to map in this segment table? It maps a two-dimensional logical address into one-dimensional physical address. Each table entry has base address and segment limit. So it is mapping with the two-dimensional address. What are the logical address into one-dimensional of physical address? So 2 dimensionals of logical address and 1 dimensional of physical address. And what are the entries which segment table have base address and segment limit? So base address is nothing but it contains the starting physical address where the segments reside in memory. It consists of the starting of the physical address where the segments can reside into the memory. Whereas segment limit, also known as segment offset, it specifies the length of the segment. So it specifies the length of this segment. So let us see the logical view of this segmentation. So this is what logical address space. So segment 0, segment 1, segment 2, segment 3, segment 4. So these are segment numbers. What are they? 0, 1, 2, 3, 4. And segment table consists of base address and limit. So base address. So segment 0 base address is 500 with the limit of 600. So it can take the limit up to 600. And segment 1. Segment 1 base address is 2500 with the limit of 800. It can take the limit up to 800. And next segment 2 consists of base address is 1500. And next segment 3 base address is 4600. Whereas segment 4 base address is 3800. So this is how we are going to map with the segment table with segment base address, and what is the limit for the base address, and we are mapping with segment number. So segment 0, segment 1, segment 2, segment 3 and segment 4. Segment 0 is mapped with red color, segment 1 with orange, and segment 2 with ash, segment 3 with brown, and segment 4 with black. So how we are going to map with the basing on logical address space into the physical address space based on this base address and limit by using the segment table. This is what about segment table, and this view is logical view of segmentation. Next, what do you mean by virtual memory? Virtual memory is a storage allocation scheme in which secondary memory can be addressed as through it were with the main memory. So in this allocation scheme, the secondary memory can be addressed through it where it the part of the main memory. So it can directly address with the secondary memory through part of this main memory. The addresses a program may use to reference memory are distinguished from the addresses the memory system uses to identify physical storage sites. So in this reference memory that are distinguished from the addresses from main memory and uses some identify physical storage sites. So it identifies some physical storage sites, and program generated address are translated automatically to the corresponding machine address. So it can be automatically translated to the corresponding machine address. A memory hierarchy consists of a computer system, memory and a disk. In this memory hierarchy consists some computer systems, memory and a hard disk that enables a process to operate with only some portions of its address space in a memory. So it consists that enables a process to operate with some portions of its address space in each memory. A virtual memory, its name indicates, it is an illusion of a memory. It is nothing but illusion of a memory that is larger than real memory. So virtual memory is nothing but it is an illusion memory and that is larger than the real memory. The basis of virtual memory is the non-contiguous memory allocation model. So the basis of this virtual memory is nothing but it is a non-contiguous memory allocation model. The size of virtual storage is limited by the addressing scheme of the computer system. So here the size of virtual storage is limited by addressing schema of each computer system, and the amount of a secondary memory available not by the actual number of main storage locations. So here the amount of this secondary memory is available but not actual with the main storage location. So the memory will be available but the actual number of this main storage location cannot be available with the secondary memory. This is what about virtual memory. Next, demand paging. So in previous session we have seen about paging. In that paging we are having paging pages, page number and frames and frame numbers. So in this demand paging, what it is containing and what the demand paging will use with the paging and what is the use with the page table and frame number. So let us see the demand paging. The process of loading the page into memory on demand. So the process of loading the page on demand, whenever if a page fault occurs, is known as demand paging. The process of loading a page into the memory on demand or when the page fault occurs is known as demand paging. Here the process includes the following steps as to the following steps for the demand paging. Let us see the first step. If the CPU tries to refer a page that is currently not available in the main memory. So if a CPU is trying to refer a page that page is not available in the main memory. So it automatically generates or an interrupt indicating a memory access fault. So an interrupt occurs. So if the page is not available, immediately the fault occurs. That is but interrupt occurs. That is used by to access this memory fault. the operating system puts the interrupt process in a blocking state. So here the operating puts the interrupt. So there the error occurs. That error is kept under blocking state. For the execution to proceed, the operating system must bring the required page into the memory. So if the page is not available, what does the operating system do? It should bring the availability or required page into the memory and then start its the operating system interrupt process in a blocking state. Suppose in the availability of the page, which the availability of the page number is not available in the main memory, what does the operating system must do? The operating system must go bring the required page and it should insert into the main memory and again starts the execution of that process. Why? Because if the page is not available, any interrupt or page fault occurs. Why? Because the page is not available in the memory. So the operating system must bring the page and insert into the memory and start its execution. That is how the blocking state when the interrupt occurs. The operating system will search for the required page in the logical address space. So the operating system starts searching for the page. What is the searching process? The operating system will search for the required page by using the logical address space. So he can search with the logical address space and he can find where the page is available. So the required page will be brought from logical address space to physical address space. Why? Because the mapping will be done between the logical and physical address. So the page will be brought from logical address and it is mapping to physical address space. The page replacement algorithms are used for decision making. So here we are taking some page replacement algorithms which are used for decision making of replacing the page in physical address space. So we are taking the page replacement algorithms by our own decision making for replacing the pages into physical address space. So page table will be updated accordingly. So each page will be updating accordingly. Why? Because when we are placing each pages with the replacement of the page replacement algorithms and we are taking the decision in replacing the each page with the physical address space and that will be automatically updated. The signal will be sent to the CPU to continue the program execution and it will place the process back into the ready state. The signal will be sent to the CPU to continue the program. Why? Because we are inserted. So that now the signal rises and then it will be sent to the CPU and CPU starts its execution and it will be placed the process back into the ready state. So now the process starts its execution. So hence whenever a page fault occurs, these steps are followed by the operating system and the required page is brought into the memory. So overall, what do you mean by demand paging? Demand paging is nothing but whenever a page fault occurs is known as demand paging. So in the memory, the page which is not available in the physical or logical address, that page should be brought by the operating system and it should be placed in the page table and it processed into the memory and start mapping with the logical address to physical address. So after mapping, the page can be replaced by page replacement algorithms and they can take with the decision making for the replacing each table in physical address space and after placing it can be automatically updated. So again the CPU starts its execution and it will place the process back into the ready state. So if by this page fault occurs, we can start the execution by inserting the page in logical address space, then or into the main memory we can start the paging again for this demand paging. So demand paging, how we are going to see this when the page is not available. So here P starts with a logical address 13 bits, the page here 3, page offset is 10. So we are mapping with 5 and it is going to page offset F, frame number, page offset. So operating system, so going for 3. And here logical address space physical address space, and here physical address. This is his logical address. Logical address, this one is physical address, and this is physical address space. And this is logical address space. So how the demand paging is occur when the page is not available? We can see the diagram and start the page which is not available can be inserted and start the execution through CPU. So in this session we have seen about demand paging, segmentation, and virtual memory and structure of page table. So if you have any doubts, you can comment in comment box. Thank you.